This tutorial builds the structural core of an Asteroid shooter game in vanilla JavaScript to demonstrate bare minimum game architecture. The entire project lives in one HTML file with just one external sprite sheet. No build tools, no frameworks, just raw browser APIs. What's missing? Sound, scoring, menus, anything that isn't fundamental to the physics and rendering. Let's be clear. Game development requires math, not advanced calculus, but you will need trigonometry for aiming, vector math for movement, and coordinate space conversions. In 1979, Atari's Asteroids ran on 2 kilobytes of RAM. No game engines, no frameworks, just raw math and pixels collisions. 45 years later, we still use those same algorithms in modern games. This tutorial tears away the layers to show you the unchanging core of space shooters, the trigonometry and game loops that survived from arcades to Unreal Engine. Back then, every CPU cycle mattered. Devs wrote tight, linear code that did the work without fuss. No abstractions, no design patterns, just pure problem solving. That's what I will try to replicate here. Let's see the implementation. We use a single game object class instead of inheritance, because for small games, switch statements in the constructor and update methods create clearer code flow than deep class hierarchies. The constructor switch handles 3 object types: player ships with mouse aimed rotation, pallets with velocity-based movement, and asteroids with wraparound physics. Each type configures its own sprite coordinates, collision radius, and behavior flags, all in one place for easy comparison. The update method drives all game logic. For ships, it processes keyboard inputs from a set, which automatically handles simultaneous key presses, without messy key code arrays. Mouse aiming uses math_atan2, the most reliable way to convert screen coordinates to angles. Bullets checks collisions by measuring distance to asteroids using math_hypot, not the fastest method, but the most readable for learning. Asteroids implement screen wrapping by resetting their position when crossing boundaries, a classic arcade technique. Rendering happens in render, where we carefully manage canvas state with save and restore to prevent transformation leaks. Every sprite draws with translate and rotate, with +p divided by 2 offset, accounting for default sprite orientation. Health bars use stroke operations with width calculated from sprite dimensions, a simple but effective user interface technique. The animate loop ties everything together with proper delta timing. Notice how all movements multiply by the frame time, t, to ensure consistent speed across devices. Object management uses basic array operations: push for spawning, splice for removal. No fancy pooling, since we prioritize readable code over micro-optimizations. Every function is heavily commented to explain both the how and why, from the set-based input in handle keys to the coded math in handle mouse. You can study this line by line, tweak variables like base velocity or shots interval, and immediately see how changes affect gameplay. This is game development stripped to its essentials. No magic, just clear JavaScript showing how arcade classics work under the hood. Let's end with some truth. The golden age of games like this was the late 70s to early 90s, when Asteroids, Space Invaders and Galaga ruled arcades. Those developers ran 8 kilobytes of RAM with 1 MHz processor. They invented this algorithm not for nostalgia, but because they had no choice. What is shocking? These same techniques power today's AAA games, just layered under physics engine and shaders. Modern games still use delta time like our T multiplier for frame rate independence, rely on sprite sheets, now called texture atlases, process input in bitmask flux. Our set is a luxury update. The math we used Atan 2 for aiming, cos sin for movement is identical to what Unreal uses for AI targeting. The only difference? They add layers, we study the foundation. That's why these 40-year-old techniques mattered. They are the Latin of game dev as a product, but alive as a root language. We are not just making an Asteroid clone, we are learning the verbs that still construct every game today. The link to the file's location is in the description. I will scroll through the code now. That's all for now. Have a nice one.